Yeah. All right. I think we should probably go ahead and get started. So this session, so session 2 of day 2 of FCon. I did it correctly this time. I did not call it COVIDCon, so I'm getting better at that already. But today we're kicking off MXChips and Dip, which is another fantastic name. Jim, is this you coming up with all the names, or is this John, Ernie?
It's been Taylor pretty much, I think. Her and Heather.
Ah, that's awesome.
No,
Yeah.
I'll bounce that back. It's been Taylor and Jim. She's got the creative ideas and Jim's got the brain behind it. So that's been all the Gatwoods this time.
That's fantastic. Well, we have the chips and we have the dip today. This is all sponsored by Blackberry Silence, and also the MX chip right there comes in this little box. It's got the Blackberry Silence onto it, and inside of the box is a really cool little IoT device. There you go. I think you guys can see that. Super excited about the sponsorship, and I think we're going to go ahead and have the Blackberry Silence team speak at the end of this session. But like all of today's FCon sessions, what you're seeing today is 100% generated by people of Fulcrum. These are the things that we're interested in, what we like, what we think is cool. So hopefully you guys enjoy it and can learn something pretty incredible or pretty interesting at least. For this session, I actually wanted to bring up an aspect of Fulcrum that I think is just absolutely phenomenal. It seems like anytime we interact with an existing customer or a new customer, it could be a new relationship where somebody doesn't really know us that well. If we interact with them with regards to John Owen's team, they always love us. So our ability to answer big data questions, solve big data issues, I think is second to none. Fortune 100 organizations, Fortune 10 organizations are utilizing us, which is phenomenal and fantastic. In fact, we just had a Fortune 100 organization, mostly led with John Owen's team, big data, along with the security team, choose us to manage their SOC environment. So super excited about that. Super excited about the value that we're delivering to our customers and the fact that we can make them feel super successful. So I love John's talk about data pipelining before Fulcrum. I didn't know a lot about data pipelining, but now I do. So you've educated me, John. And so I guess the ask that I have for everybody on the call, if you've got any questions, try and find John Owen or try and find one of your sales reps, and they can set up a meeting to be able to go ahead and maybe do the Fulcrum challenge with regards to big data. But with that, I'm going to hand it off to the team, to Jim and Ernie and John. There you go. I talked about Ernie earlier today. I don't know if you were on that session, Ernie, but I had a lot of good stuff to say about you. Okay.
Thank you, sir.
Yeah, of course. Yeah. I think we got 3 of the smartest guys in Texas here on this call.
We'll see about that. Let's see how the session goes.
Asking it at the end of the day.
Yeah, exactly.
So this session is split in 3 parts. There is this part, which is getting the devices set up. In this part, we want to get your device set up, connected to the cloud. There is a middle session that I'll be hosting for, and it's a meeting. So anybody in that meeting will be able to talk, interact, ask questions. We'll be able to troubleshoot. We'll try to troubleshoot some problems. You can share your screen, stuff like that. If we're having trouble getting your device connected to the cloud. And then the last session is going to be where we actually show you why we did this, and give you some use cases as to what this device can do. So I will turn it over to Ernie.
Good morning, everyone. Ernie Martinez, Director of Digital Transformation here at Fulcrum. So what does that mean? It just means all things cloud. So a little bit of background about myself. So I've been in parallel distributed computing for a long time. My background is in electrical and computer engineering. I've spent a lot of my life in open source development, high performance compute, HPC. So a lot of RPC procedures, MPI drivers, Linux embedded drivers. So that is my background. So operating system design, operating system optimization. Prior to Fulcrum, worked on at a small company called Rackspace, where we worked on OpenShift and OpenStack, or actually OpenStack and OKD, which is another project now called OKD. So that is the foundations of cloud and cloud data centers. So if you guys have any questions around cloud, definitely reach out. I can go from everything from data center design, global data center network connectivity, and how to integrate with your current points of presence. Thanks, Jim.
All right, thank you. Most of you know me. The director of the Managed Cybersecurity Services. I manage a team of very smart SOC analysts that we do endpoint detection, managed detection response, and we do managed SIEM services, generally tier 1 through pulling the emergency ripcord when there's an incident or something that needs to be looked at. So just depends on, yeah. And hopefully you guys didn't hear that. Somebody was trying to call me in Teams. Figures. I got my phone muted, but I didn't have Teams muted. Where was I at? Okay, so we do lots of security services, and so anybody interested in that, come talk to our sales staff, and I'll get that set up for you. Blue teamer, and I'm a hardware hacker. I'm a technology addict. I like small development boards. I have a very bad habit of buying anything I see is when it comes out as a development board or a new small type of microprocessor. I have ESP32s. I mine Duino coins on my ESP32s, and I have far too many Raspberry Pis in all parts of my house. So I'm kind of IoT crazy, really. I also have a separate VLAN, and I keep them all contained. So, John?
I don't know if I can follow the intro from Richard, but yeah, I'm John Owen. I lead our security analytics team. So generally, we, like I said, find interesting things and for fun and food. I'm a car enthusiast, if you are aware of that. I cycle hobbies fairly regularly from one thing to the other, and tinker, fix, and subsequently break things. So also like cybersecurity education and advocacy. So yeah, happy to help on any of your data security needs. Please reach out. Thanks, Jim.
Awesome. All right, so that is the short link for all of the presentation files. Bree also shared that in the Zoom chat, so you all should be able to see that. So I won't hang around there too long. So what did you get? You got a MX chip AZ3166 in your care package. That little development board and is it's kind of designed to be attached to Azure, but truly it's C programmable. I got some links at the end of our other sessions or in this presentation that you can do other things with. So you can program it with Arduino IDE. You can do it's programmed in C. There's just lots of stuff. Now this board is amazing to me because it's got so much in such a little package. Some of the big things are the motion sensor. It's got a 6-axis, is it 6-axis? I think it's 6-axis accelerometer. It's got a magnometer, which gives it a couple of its axes. Pressure sensor, so it gets the actual barometric pressure, humidity, temperature, you name it. It's got all kinds of stuff. It's a little microphone. I guess if we wanted to snoop in on you, we could. Just for a disclaimer, that is not enabled in this demo, so we're not listening in. not trying to be Alexa or Google Home or anybody else. It's got an OLED display, so it can display things. It even has a built-in A to D converter for audio, which is also not part of this this actual demo. Infrared emitter sensor. It can transmit and receive IR. There's lots of stuff this board can do, and we're just going to scratch the bare surface. It's kind of the block diagram of the board. Real big highlights: 2.4 gigahertz Wi-Fi module. You will need a 2.4 gig side to be able to connect this board. If your house, if you're using Wi-Fi 6 only, or you've got, you know, some crazy A only connection, it won't connect. You'll definitely need to connect it to your, and if you have multiple ESS or SSIDs, you'll need to connect it to the SSID that is 2.4 gig. Ernie.
All right, so thanks, Jim. So, you know, when we think of Azure, oftentimes we're thinking lift and shift. But we wanted to highlight here are other things that you can do beyond lift and shift, right? And hybrid Azure architecture, infrastructure as code. What we wanted to highlight here is where the cloud market's going, where edge compute is going, and what this IoT ecosystem looks like. There's a few devices that you can connect with Azure IoT Central and even IoT Hub. But primarily, the devices that you can connect come in essentially three flavors. An Azure IoT SDK. So this is like a Linux embedded system that you can deploy onto your microcontrollers. An Azure RTOS. This is what we have here with our MX chip. It's the Azure real-time operating system. And then you have Azure Sphere. So what does that look like? Azure IoT SDK. Well, in the home lab, I basically have this guy, right? So my little emulator box, Nintendo, running on a Raspberry Pi. That's connected via the Azure IoT Edge, and I'm able to use an Azure Hub application. If you look at Avnet, here's another one. So this is Azure Sphere. These are different types of cards that directly connect to Azure Edge via command line interface. So this is very much programmatical at scale. There's not a GUI interface. You're not using real-time OS from Azure. But what we have here is essentially why Azure IoT. What is it about Azure IoT that makes a difference? Well, it's the way that we can connect. We can connect telemetry, IoT Edge, based on what are some of the millisecond latency requirements between the reporting. So if you deal with IoT, it's not the same time you can't submit as much traffic as you would, say, on a traditional corporate LAN. You have to be very selective as to what packets you send out, what telemetry you capture. From a provisioning and management of IoT devices, that's where IoT Hub is key, because you're able to pre-provision registration keys for our IoT devices and manage those keys to connect back. But then what is it that you really get with Azure IoT Central? Well, it's what you want to do with the telemetry. What type of information do you want to capture from these devices and send? And then how do you aggregate this telemetry? How do you manage the devices at scale for reporting? And then how do you create the business reports for all of your IoT devices and sensors? So when you look at the Azure IoT ecosystem or Azure ecosystem, it's not just lift and shift. It's not just web servers, not just SQL. It's not just an IIS instance. You're now seeing manufacturers leverage Azure IoT to capture all the telemetry from sensors, including HVAC. So just one way to leverage IoT, the Azure IoT ecosystem, and we're just going to do a small touch the surface sample of how we get many devices communicating to an Azure IoT application and create a small analytics report out of that. Thanks, Jim.
All right. So basically, the block diagram of what you're going to be doing today is we're going to have a hive, hopefully, of all you attendees connecting to your AZ3166s. We're going to be connecting to the Azure IoT. It's Azure Cloud IoT Central. IoT Central simplifies a lot of the stuff that Ernie showed you in the previous. It encompasses a lot of the like the IoT Hub and all of the other things that have to be set up. So we went with the most simplified version. just because of time constraints. So your devices are going to connect to the gateway. I'm not sure if it's this one. I think this one uses HTTP in its connectivity. So it's going to connect to the gateway. The gateway connects to the IoT Central. IoT Central is a repository and management interface for these devices. So it does provisioning, device ID information, things like that. It also allows you to connect and output that telemetry to other devices. And John's going to be talking about Cribble. We use Cribble in the middle. That Cribble's in transfer in Splunk Cloud. And John, you want to explain Cribble?
Yeah, absolutely. So yeah, Jim mentioned Cribble, and why are we using Cribble? Because Cribble is a great tool, especially in this capability. So we're actually using Cribble to reach into the IoT Hub's Hub Sub capabilities and actually pull that data feed, collect it, enrich it, and then send it over to Splunk. So it acts as kind of an agnostic data router in this sense, data collection and forwarding utility. That's not only is an ease of access tool for us. So in a quick situation where we need to spin up an environment and test with data sources that may be highly varied or we don't really know a lot about, which is perfectly fit for this IoT data source. We could just fit Cribble in and really plumb our data pipelines really easy. This is, again, like a logical overview of the platform. We're using obviously a much simplified version where we're collecting from a single Azure VitHub and sending out to a single Splunk instance. But again, the flexibility of this tool allows us to do it very quickly and then have the capabilities to scale up from there. So quick overview of Cribble. We'll do a little more of a deep dive from a technical perspective later in the session after we get everybody onboarded.
Yeah, I can't say enough good things about Cribble. We have some very large organizations that have spent a lot of money, time, and resources trying to create data pipelines, and Cribble simplifies a lot of that. One of the things Cribble, I don't know how the data DSP, the Splunk's DSP is coming, but it used to not even understand the native Splunk forwarder. It tried to you'd lose the metadata. One of the things Cribble does is it'll take a Splunk forwarder and maintain that metadata all the way through the pipeline, which was awesome if you're a Splunker like me.
Absolutely.
Okay, now for the hard stuff. Programming the development board. The development board, and I guess we probably should have put out a statement. You're going to need basically a Windows VM or a Windows PC. This demo and the code is not technically designed. Now, you may be able to get it to work on a Mac. I've not tried it, especially the way I'm doing it, because you're going to basically clone a Git repo or get a copy of the zipped repo that's in the files that I provided. And you can unzip that if you're not a Git person or have Git installed. If you're on a Mac, maybe you want to try it. Go get the repo that we'll have here, and we'll try. It probably won't. I guess I know why it won't work, because it won't install the tools. It launches PowerShell to install the tools, so there's probably lots of dependencies there. Let's see. If you were signed up for this course, well, I think everybody. I think I sent this out to everybody, every attendee that was signed up for any course. Yesterday and the day before, there were a whole bunch of emails that went out. The email is from myself, Jay Gatwood at ftsc.com. That email usually is titled MXChips, something in the subject. It has your IoT information. It has your device ID and it has your key. Those two things are important, and also has the instance. So there's three components that you absolutely have to be able to connect this chip. And then, as I stated before, you'll need your 2.4 gig Wi-Fi SSID and passphrase, assuming you're using pre-shared key and AES and not WEP. There is a way to hook it up to WEP, and there's a way to hook it up with no. But if you have that in your network at this point, and you're a customer of ours, you either need us badly or you know, one or the other. Okay, so I'm gonna try to go a little bit slower. Installing Git. So you can download the Git install, and basically I didn't have to check. I did this on a version install. Did not have to click any extra options. So basically went and downloaded Git, clicked install, said next. Thank you very much. And that was all I had to do. The next thing is you're going to want to create a working directory, and you want to make it short. And the reason is, if you put it in your My Documents folder, especially if your Documents folder is linked with your OneDrive, it creates a very long name. And in the compiling procedure, that becomes a problem because I hit that wall. So you will want to create a working directory, probably right off the C drive, call it MXChip, super simple, MKDIR, right click in your Explorer, create it, however you want to do it. The next thing you want to do, though, is then open a administrative command shell. So you can use command, PowerShell, Git, or Git shell. Git shell is a bash version. I really would suggest using just a regular command shell. Seems to work just the best. It's super simple. You're not going to have to do any crazy PowerShell commands. The script does it for you. If you downloaded the zip file, extract the getting started zip file into your MXChip. So MXChip, then subdirectory getting started. Okay, if you did not, you can go to command shell and enter in your Git, and I guess I could probably pop up command shell. Wrong thing. Okay. I got one on my G drive. Forget would. See.
Can you make it a little bit bigger, Jim?
Yeah.
Thank you.
You are correct. And let's see if I change the font.
Yeah.
Where's the font here in the properties? Yeah. Let's change the size. Let's go. Okay. Oh yeah.
Nice. Thank you.
Movie bigger. All right. So I have already cloned the Git repository. Let's see, I started to do LL. Basically, there'll be, say what, John?
Say a quick reminder, it does need to be an administrator prompt. So right click on CMD, run as administrator if you need that.
Yeah, it does. It makes things much better if you don't do it as administrator. Your compile, I think your compile fails. Okay. Yeah, and there is a tech support right after this, so we'll be taking anybody that didn't has issues. So, I guess I'm just gonna get out of the demo. How are we gonna do this? I should have a text file of all the commands.
And we can fling through the rest of the PowerPoint while time permits and then switch over to the tech session and
Yeah.
follow up with
So,
slides.
so just so you can see this, this MX chip directory, I created a directory. I did my git clone, and git clone created this getting started. If you're unzipping, if you've downloaded my zip file, unzip it to this, unzip it to getting started right here. Make sure that that fits. That way all the commands, all the stuff you can copy paste out of the presentation just works. I don't know if, let's see. Let's go back to the presentation. Next step after you've got your repo down or you've got your code in place is to do the prep. So what this does is running this command, and you can do that just from that command line, no slashes in front, just paste that sucker there. It will launch a PowerShell window and install the tools and install a GCC compiler. It'll install CMake. The compiler is the ARM version of the compiler. It'll install CMake and Termite. GCC is, is a C compiler. If you're not familiar with compiling in C, I know a lot of us took C in college. A lot of people didn't, but it installs a C compiler. CMake allows you to create an install and just basically do all your compilations and put the files where you need them and set permissions and all that good stuff. Termite is a program that we'll use if you have to troubleshoot. So that'll be in the troubleshooting stage. But basically, you should see the PowerShell window come up and look like this. It'll say downloading, installing, I'm done, press any key. I pressed any key being a space bar and it didn't like it, so I hit enter and it worked. So just in case you have issues getting that to continue, hit enter. Make sure you're clicked in the window and hit enter. All right, so this step is very important. You will want to close that existing command window you just created, that administrative one. The reason for that is the installation of these tools, of this tool chain, requires the setting of some environment variables. If you went to type CMake, in the next step to check the version, if you do that, it'll come back, it'll go say, I can't find the file not found. So file or command not found. So you'll want to close your command window and then directly again, open an administrative command window, do a CMD, type it down in your search and right click and tell it run as administrator. Change back to your directory, your MXChip directory, and then directly enter CMake version. Oops. Back up here. Went the wrong way. So and you should see something like that. CMake version. Maintain supported. So if you get that, then you're on the right track. Okay. Now comes the interesting stuff. Deep inside that directory structure, under getting started MXChip, AZ3166 app Azure, our app is a config file called Azure_config. You have to configure your information for your Wi-Fi. So you'll need your Wi-Fi SSID. You'll need your Wi-Fi password, and the mode should already be, and normally will be WPA2 PSK AES. If you have another mode during the troubleshooting session, you can get with me and we'll work it out. You can also read the very beginning of the config file to get what you should put in there. Okay, So then in that email that you guys were sent, and if you don't have the email, we can provision that too in the troubleshooting session. I can do it on the fly, working with you. You will need your scope ID, and that for all of us in this session, the scope ID that tells it to go to our instance is this, and that's a 0 NE 0065283B as in Baker. That's also in that email, copy paste, so you don't have to worry about it. Registration ID. That registration ID is your device ID from that email. So it's in there. I think I create a little table and make sure they even match. The scope ID, registration ID will be close together in the session. In fact, I think I'll just go pull that up in Notepad here in a second. The device SAS key, that is near the bottom of that configuration file, but you'll find where that's at. So let's pull that file up, take a look at it. Where's my notepad? If you want to type in a command to open Notepad to edit that, just from your command prompt, type in Notepad, add space, getting started. You can, copy paste that from the presentation file. If you download the presentation file already. I'm trying to see if I got my file started up. And I don't. Let's just go find it. So
we have a question in the chat.
yes.
How long are the Azure IoT Central credentials we have been provided good for?
So that's a good question. John, you can answer that because I don't think we've discussed how long we're going to leave it up.
Yeah, so there is good for as long as the instance of IoT Central that we have as the hub for this is actually provisioned and available. So I think we're gonna sometime tonight or tomorrow, it'll get cut off.
Yeah, we're going to have quite a few devices, so I think we didn't want to incur a huge amount of cost. In fact, at this point, I'm not sure what cost we're going to incur. This is, I think, the free version. I don't think we had to update it to paid. I think we had 500 devices under the free version, which is quite a bit. There's just a rate limit under the free version as to how chatty these things can be. And this getting started tutorial is not as chatty as some of the other stuff.
Yeah, what we're going to go through, and to Spencer, your point, is a setup that you can do on your own independently, even using the free version of Azure IoT Central and IoT Hub that they provide for you. You can set up that with a couple clicks and use the same process to configure it with your own key and send this in yourself. So it's use the same process to configure whatever you'd like the device to do.
And I think there was a QR code in that box that takes you right to the getting started, going to the IoT Hub and all of that. So that shouldn't be. Let's see. Why can't I get back to presenting this slide? All right, fine. I'll just get to it.
There it goes.
Yeah, it wouldn't let me present, man. So, all right. So I basically just typed in Notepad, getting started. Like I copy pasted out of the presentation. So let's open that up. That opens Notepad in my other window, of course, where you can't see it. Let's see. How do you increase this thing? Oh, there it is. Okay. All right. So this configuration file, and I just literally opened it in Notepad. Oh, yep. You can see my information. Great. Now you know my info. I have to change that. The IoT DPS scope. That's the scope you put in there. The registration ID will be your device ID. And your SAS key will be placed down here at the bottom. Literally, you'll save that, exit out. It didn't ask me if I wanted to save because it's already there. And then on to the next step. Here are my. Okay. My radio in the background. I don't know if you guys did or not. Okay, so the next step is you'll want to run this command. Now go ahead. Oh. Don't like that I can't copy paste off that. So you want to run this command, the getting started, MXChips. Basically, you're telling it to do a build. So I'm going to tell it to do a build. I guess I could have been pasting these in the. Start pasting these in both places. All right, so I'll do a build. And it's a rebuild. So if you have a change to those, change to that file, and you change your config up, say you got your password wrong, you put in the wrong SSID like I did to start with, because I couldn't remember that I was camel case versus all caps. Anyway, if you fail the first time, all you got to do is change that config file and you can do a rebuild. So here we go. We're going to do a rebuild. Takes a little while, but not too long. Okay, maybe I lied. It's taking longer because I'm presenting.
But towards the end, it jumps really big. I guess kind of little behind the scenes as what this is doing is it's taking the application package, basically that we downloaded for that Git, is a predefined application package built for Azure's, like Ernie mentioned, RTOS, their operating system. You've edited a configuration file to tell it to connect to your Wi-Fi and then connect to our hub to get our profile, which tells you what metrics to get. And so you're basically building an actual application specific operating system component that you're going to load onto the device. And this is the same process if you want to do full C configuration and your own programming. It's the same process to do the compilation.
Yep, if you're a programmer, you're definitely familiar with this.
Yep.
All right, and the next step is it's finished. And so literally you can see where it copied it out. Now where it copied it to, I just pasted into the, nope, I pasted it to backstage in the chat. Oops. All right, just pasted into the chat. And you'll want to go to that, and let's open up File Explorer. And we'll go to this PC. We'll go to the G spot. We'll go to MXChip. Get it started. This thing's buried. MXChip, and you'll probably want to do this from a File Explorer. So you'll want to go traverse this path from a File Explorer. So, where was it at? Build app. All right. So this file here, I don't know how to make this bigger. The MXChip is your IoT.bin. So you'll want to grab the .bin. And actually you don't have to grab it. Just right click and say copy. Okay. So after you've copied it, you want to grab your IoT device, and we're going to shrink these down for now, get them out the way. We're going to go back to the presentation, and I'm going to go to how to flash the image. All right, so here's a picture of your board. This is the AZ3166. I'm taking a new one out of the protective package now. So you have a board. On that board is a micro USB connector. In the box is also a micro USB cable. So you want to get that out. And then really there's not a whole lot you need to do to this thing. You because of the firmware that's already loaded on that, it portrays itself to the operating system, especially a Windows one, portrays itself to the operating system as a flash drive, which makes it really easy to upload the code. You don't have to have any special program or bootloader or any of that stuff. It's already on the board. So basically I'm plugging mine in right now under this clean one. I should have provisioned myself a secondary site. So basically in a file explorer, and I'll pull up another explorer. Okay, so if I go to this PC, you'll now see one of your drives has a label that matches that dev board. So AZ3166, that's my drive E. To program this board, you simply, I had you copy, you'll simply drag that file over or just, paste it in here. It'll paste, it'll start copying. You'll see some LEDs start blinking. I think the multicolor next to the display will turn red. It'll copy. The board will reset. And it should be connected. It'll drop off and it'll reset. And at that point, you're connected. So if we're connected to the cloud, we can look at your dashboard. I actually have that here too. So let's zoom this a little bit. Control. So try and find my device ID. All right, there's my device ID. And it shows me as provisioned. So my MX chip data, I'm using the MX chip template. I drill in here. I see my data for my MX chip, and you can tell the temperature actually went down in here a little bit. AC must have kicked on. But that's basically what we're looking for. You guys will not be able to see that. However, you will see successfully, if it's successfully connected. It's not in there.
Now I've got a board if you want to jump over there.
Say what, John?
I can share the onboarding dashboard if you want to see if anybody's able to get connected.
Oh, okay. We also have what you'll see if it connects completely, you'll see it say Azure IoT on the screen. So if it's connected and it's connected up successfully, it'll say Azure IoT. Must have lost my picture page in between our group editing of PowerPoint. You gotta love that kind of collaborative PowerPoint editing online. I do have a picture of it, but I'll stick it in there. Okay, where would you like to go from here, John?
I can show the onboarding page and see if we've got anybody that's getting close.
Okay. Let's see. We had. Let's see. Taylor, how long is this session?
We've got 9 minutes.
9 minutes. So that's what I thought. Pretty short.
Then we'll take it to the next support session.
Yeah.
Okay.
So let me
Well,
this screen now.
you're going to share that so that there is some troubleshooting information that is in the it's in the presentation. It tells about loading the drivers, the USB drivers, to be able to connect to it through a COM port. That's explained. So John, I'll let you go ahead and share.
All right. All right, so and we'll show the same screen in our troubleshooting tech support session. But what you'll see kind of here is we've got our 3 test devices that we've got connected here. The newest device will pop up here on the top for those of you that are able to compile the binary and then get it uploaded and connected through your Wi-Fi and our hub and everything. So yeah, once we start getting those provisioned, they will show up here and we'll dive into what we're doing with some of the little bitty data from the metrics, the sensors on your devices after that. So we'll look at this to update over time.
Yeah, right now it looks like it's pretty weak. It's my 2 devices here at the house plus yours.
Mm-hmm.
Yeah, somebody had said they can't do this on their work machine. I'm wondering, we need to find out if there's a cost associated with this and see if maybe we can leave it up for a couple days. I know your stuff there is, right, John? Your Splunk side.
Yeah, we've got, that's probably the biggest one is cores. So we could probably, I mean, let's check. I mean, I imagine we can leave it up for a little bit.
Because I know Gail had mentioned here in the chat that she'd love to do it, but she's not allowed to do it on her work machine. She'd like to do it when she's at home.
Okay.
Yeah, I kind of figured that'd be the case for some people.
Yeah, we'll cycle around. Again, there's I think a QR code that came with the device. If not, we'll send out a link. But if you want to jump start on that, you can search. There's a link.
Well, that link is attached to the end of this presentation. I put that in there. So there's a couple ways you can slice this device.
So if you want to practice at home, so you can actually subscribe to IoT, IoT Application Central, and you get 2 free devices and up to 800 messages a month. Once you go beyond the 2 free devices, then you start paying for the standard tier, and that ends up being 1 cent per 1,000 messages and 40 cents per month per device.
And it's not terrible. If what you want to do, some of the examples of IoT stuff, I've used an app called Blink IoT, and just because that was the easiest to use with my ESP32s and my Arduino environment, that Blink IoT app, I've created my own. I don't know if you can see it behind me or not. Let me turn off my background. Okay, yeah, let me. Boom. Turn that up, zoom that in. So back there, you can see that string of LEDs changing color in my background. I created an app on my Android phone through that Blink IoT that I can go to that Blink IoT and I can change the color. I can make that turn off that rainbow. I can make it do a Cylon. Let's see. It'll change here in a second. That rainbow has to cycle through. That's the other thing. These event hubs, these are bidirectional IoT devices. So you literally can send a command. So like right now, you can see it doing the Cylon, where the red's going back and forth. Or I can do, let's see, I can do red, blue. Make her change. I can set it to any color I want. You got a color wheel. There's just all kinds of things you can do with IoT devices. I know there's some on the Azure side also that allows you to create like an app that you can access and see this information, even, you know, without having to connect it to a data and analytics system completely. It's got its own kind of small data logging system within it. And we're a couple minutes till the end of the session, and then we'll be rolling over to the support session. The support session is going to be open format. You guys will be able to share your screen, raise your hands, turn on your mics, all that good stuff. Things like that.
So I just want to say, if you want to play with additional sensors, so DF Robot has a fun kit. So in this case, I have temperature sensors, flame sensors. I have voltage to determine soil moisture. So I have soil moisture sensors. So some things that I use out at the ranch just to determine like how the crops are doing. So I'm able to monitor the crops using this MX chip with a Verizon LTE.
I don't have a kit. I have a whole stack of drawers with assorted sensors, displays, IoT devices. This device is not Python capable that I know of. There is a version of Python called Circuit Python that is built for ARM and IoT devices. I don't know if that can be loaded on this or not.
Yeah, I have not tried actually. I have not.
I'm sure you can connect with the Circuit Python devices, or even the Raspberry Pi. The Raspberry Pi can connect to the event or the IoT hub. So you can slice and dice it many different ways.
Yeah, I believe it's like C based on Arduino at the core, though.
It is. It's an Arduino core.
Yeah.
Awesome. Well,
Yep.
thanks everybody for your time today, and we'll see you on the tech support session if you do have any questions, and follow up with some data.
Yeah, hopefully some of you guys could actually do this on the work computer. I didn't think about that being during work time. Load up a virtual machine, do it on your virtual machine. Be sure you pass through the USB and you're good. All right, see everybody.